All right, folks, let's go ahead and let's give this a try here. So what I'll be doing for you is that I will be posting pre-recorded lecture videos for you, and I'll post it on Edpuzzle. I went over with you yesterday how you go about answering, watching the Edpuzzle videos and answering the questions. I'll quickly go over these slides with you again today. It seems like yesterday I had an internet connection issue. It sounded like it seemed like with the comments you were making on yesterday that the video was lagging. So some of you probably had an issue, had a difficult time trying to follow the lecture. And this is the reason why I want to switch over to the this format here. Is that this way, then there won't be any issues with lag time or any issues with the connectivity. So that way, then if you have any questions, understand while you are watching the video, I will be in front of my computer. You can ask questions to me through email. Okay? You can comment on Google Classroom. So if something comes up during the course of the video, the lecture that you have problems with, make sure you email me, email me or comment in the Google Classroom. And that way I can answer your questions at that time. But do understand you are also able to attend our Zoom classroom tutorial from 3:15 to 4:15 if you have any questions about this as well. So please make use of those options for you. You can get feedback immediately through email or through Google Classroom, or you can come by after school 3:15 to 4:15 to get help on whatever you had questions you may have had from the video. Okay. All right. So I'll go ahead and do that real quickly. I'll go over this with you. I will also post for you. I'm in the process of finalizing the lecture notes here and the course, the material for the kinematics unit, and I'll post that for you as well. Again, I'm going to try to keep with the spirit of our Principles of Engineering class, and I'll try to incorporate more hands-on activities for you to do, and I'll post that as we go along. And then what I'd like to do then is get started with this, but one quick announcement, and I will post it on Google Classroom as well. Since we are losing time each day, since we're on a number 4 schedule, the Friday schedule, what I've decided to do, and I've been given the okay to do this, I would like to have class on Friday as well. So Friday, we'll meet also 12:50 to 1:25. So instead of meeting just 4 days a week, 1 hour each day, we're going to meet each day now. So Monday through Friday, we're going to meet from 12:50 to 1:25. So we'll be going 40 minutes each day, but we got to make sure we cover the material. We need enough class time to cover the material. And so we will be meeting from now on Monday through Friday, 12:50 to 1:25. And again, I will make note of that for you on Google Classroom. So please make sure you keep that in mind on this Friday. Okay. Outside of that, I think that's it. Let me just quickly go through with you then, basically what you'll do. So make sure then, starting today, and you guys have been pretty good about this, make sure you log on to Google Classroom. There you will have to check in through the attendance. So I'll have a section for the attendance. Just make sure you comment that you were here. Always I can take roll. Then from there, you can go ahead and watch the Edpuzzle video for the lesson, which is this video for today. Make sure then that the problems that are assigned to you, the problems that you have to do, you work that out on a separate sheet of paper. And I pointed that out to you yesterday, and I'll point it out to you again. Make sure you write your name, the period, and the class, and then also the date. And then you go ahead and you write out the problem and you write out your answers. So make sure you show all the work on that piece of paper that you will turn in and submit through Classroom. Okay. Once you're done with the video, there will be, towards the end of the video, there's going to be a question, maybe 2 that I will ask of you. Every once in a while I will ask of you, that you will also have to answer on that paper that you will submit. Okay, so when all that is done, you will copy the answer onto your paper, and then you'll submit everything through Google Classroom, and I will have a place for you to submit that work as well in Google Classroom. Okay, so please make sure that you please make sure you submit the work on time. This is typically, and I will try to make sure then that I will record long enough. So right now I'm going to record about a 20-minute lesson for you. That'll give you enough time to get the work done in during the period as well. That includes the problems that I'll ask you to do in Google Classroom here, in our lecture here, and then you'll post it on time. Okay, so we'll give it a try. We'll see how it works. Obviously, since this is the first time for all of us, I'll be tinkering with the time. But for my other classes, it seems like with the 20 minutes, it seems like that's been working pretty well with the adjusted schedule. Okay, so please make sure that you watch the video, get the work done, submit the work to me before the end of the period, which for us then will be at 1:25. Okay. All right. So how do you turn your work? Well, for example, if I give you this class, this problem here to do, which is what time does the first period start for the day? You will write down your answer. And so this is the work here. So if you notice here, I have my paper here. And if you notice then, what I've done is I've written my name. I've written my name. Oh, come on. Okay, sorry, this doesn't seem to be cooperating right now. Okay. I've written my name at the top here. Anyway, the period number, that will be period 7 for us, and our class would be Principles of Engineering, the day, and then the date. I would label then the class problem here. Okay, so that means then let me see, the problem here, and then I write down my my answer. Then what you would do then, you submit the answer through Edpuzzle. Okay, you will submit your answer through Edpuzzle. Okay, and then you'll start the video, and then I do the work for you. I give you the answer, and then on your paper, then what you would do then is you would write down the solution here that I had given you, and you write that down underneath. Okay, so make sure then that you include that in your paper, and this is what you will turn into me by the end of the period. Once the video is done, you'll turn this into me through Google Classroom, and this is what I was trying to get you to do yesterday. And so please make sure after the video today, if you have any questions, you can watch the video again, rewind it, and get your questions answered. And if you still have some questions about this, please come by after school today, get your questions answered, or just email me and or comment on Google Classroom. Okay. All right. So I think then with that said, then this is pretty straightforward. Make sure then that you submit all your work through Classroom at the end of the period at the appropriate place, and then you'll be done for the day. Okay. All right. These practice problems, you won't have these for every lecture, but I will include a few. Let's, for example, if we don't finish up a problem by the end of the lecture, by the end of the period that the time that I have allotted here, then I will ask you to do it as a practice problem. You include that on that paper that you use to do all the work during the Edpuzzle video, and then you'll submit that as well through Google Classroom. So make sure you include all that work and for submission, and make it available and ready for submission. Okay. All right. Keep this in mind then. There's our office hours. Make sure you keep that in mind. Those sessions will be live. That means then you'll come in, you'll meet with me. My other classes will also meet at that time, but we'll keep going until I've answered all of your questions, everyone's questions. So come on by with your questions. We'll take turns, and then we'll get things done. Okay. So I think you have that information there. That's the Zoom link there that you'll need in order to get to our office hour, and then come on by and get your questions answered. Okay. That's it for the administrative stuff. I hope then that clarifies some things for you. With the time remaining, then I'm going to go ahead and get started with the unit here that we were supposed to do towards the end of the semester, but we're going to do it here because I think this works out well for us. Okay, so we're going to be studying kinematics. Okay, so we're going to be talking about kinematics, which in physics is just the study of motion. It's the study of motion and the quantifying of motion, the quantifying the different aspects of motion. And so what I want to do here is I want to start out by talking about what motion is, how we represent motion, give some basic definitions of motion. So essentially what we're going to do is we're going to focus heavy on the physics here. So this is going to be much more physics-based. And so, I think for many of us, this will be new for us. A few of us, you've probably already studied this in your physics classes. So, bear with me as we go through this, but I'm going to introduce this and teach it at a very basic level. And so I think so that we all can pick up on it. Okay. So understand this, the area of physics that studies motion, it's called mechanics. Mechanics is essentially the study of moving objects. Okay? And actually the study of mechanics, since every object, everything is essentially in motion at certain levels, The study of mechanics is very far-reaching. It is broad. We can use that to study not only motion that we see here on a daily basis, but we use mechanics also to study the motions of stars and planets. But also we can use mechanics to study the motion of atoms and electrons. There, it's called quantum mechanics, but it's still the study of motion. Okay, so mechanics is a very broad field, a very broad area of study in physics. So what we're going to do is we're going to narrow it down just a little bit initially, and we're going to study that aspect of mechanics called dynamics. Okay? Dynamics is essentially the study of motion, but what we're going to do is we're going to quantify that motion, which means then we're going to assign numbers, we're going to assign units to that particular, the different aspects of motion. Okay? So understand this. What makes the study of mechanics sometimes intimidating for people is that we're assigning numbers and we're assigning units to something that we are familiar with. So do you understand this? Mechanics we see on a daily basis. And when I teach physics, I always try to point out to folks then that motion is the most easily identifiable aspect of our world. Okay, so we recognize motion fairly quickly. We can identify it. And so understand what we're doing here in physics is that we're taking what we know on our daily basis, and we're just going to assign numbers and units to it. Okay? And so what we got to do then is we're going to have to make a way to visualize that motion. That means then we're going to learn how to graph and use different ways that we can describe that motion visually first. Then we're going to go ahead and take this visual representation here and use vectors. And most of us, we're all familiar with vectors. I introduced that to us already. We're going to use vectors then to describe that motion as well. So essentially what we're doing here is we're going from concrete, real descriptions to more and more abstract so that we get to the point then where we can describe that motion in terms of numbers and units. Okay. So with that said, then dynamics is a fairly broad study. Okay, so we're going to assign, we're going to quantify motion in dynamics, and so what we're going to do then is with kinematics, which is a branch of dynamics. What we're going to do is we're going to describe that motion for the most part in very simple terms, in terms of acceleration, in terms of velocity, in terms of displacement. Okay, and so we're going to assign it very simple descriptions. And essentially what we're going to do is we're going to focus on the motion itself without basically ignoring the causes of that motion. The dynamics study quantifying motion in all its aspects. With kinematics, what we're going to do then is we're going to focus on that part of motion that is going to describe the most basic parts of the motion with ignoring at the same time, ignoring then what the cause is. So we're going to leave out of this discussion for right now forces. So we're not going to discuss forces, which is what causes the motion. Okay, so we're going to make it very simple. Okay, so for right now, then there are going to be three quantities of motion that we're going to focus on: displacement, velocity, and acceleration. We're going to define each one of these three here. We're going to define all three of these, and then we're going to assign then certain units. We're going to describe them first, and we're going to assign units, and we're going to talk about how we can calculate for each of these three quantities here. So all motion can be described basically in three very simple ways. Displacement, which is how far an object moves and in what direction. Velocity is how fast it moves and in what direction. And acceleration then is how fast it changes that motion, how it speeds up, how it slows down, and then also we have to consider that in terms of its direction as well. So these three basic concepts here, folks, is what we will be focusing on for the most part for the first part of this discussion of kinematics. Okay, and so you really need to make sure you understand then what these are and how to calculate for them. Okay, all right. So motion's all around us, folks, and I just want to start out with some basic discussions here. Everything is in motion. Everything is motion. When I'm sitting here and it doesn't look like I'm motion, on a macroscopic level, I'm not moving. I don't undergo any displacement. My velocity is zero. My acceleration is zero. But then if you imagine this, my cells are moving, the atoms that make me up, they're all always in motion. So motion is all around us. And motion can be described in a number of different ways. You can have an object that's moving in a straight line. You can have an object that's moving in a curved manner, a spiral manner. We recognize these types of motions as different from one another. And motion is instinctively, we pick up on motion fairly quickly. For example, I always bring up this example here of camouflage, and that is the key characteristic of good camouflage is that the not that the object is blended in with its environment, which is important, The object has to be able to blend in with its environment, but the key to camouflage is that the object cannot move. So if you have a moth, for example, and it's perfectly able to blend in with the tree because the color is fine, your eyes will not perceive it, or a prey, the animal that wants to eat that moth, will not see that moth unless that moth moves. So even though that moth is perfectly camouflaged in there, as soon as it moves, the eye is going to shift directly towards that motion. So we are trained, our minds are trained to detect motion. Okay, all right. And so with that said, then, when objects are in motion, essentially what we have is that the object is changing its position. It changes from point A, it moves from point A to point B, it shifts from one point to another. And that's going to be the most fundamental part of motion. That's how we're going to describe a moving object. Okay? What we're going to do then is we're going to ignore the curved motion, we're going to ignore the circular motion, we're going to ignore the spiral motion. For the very first part of this unit here, we're going to focus specifically on an object moving in a straight line. And so this is what we call one-dimensional motion. Okay, so this is one-dimensional motion. And so the description then will answer two basic questions. Where is the object at a particular moment in time, and when did that object reach that particular position? Okay, so we're going to talk about, basically when we talk about this, we're going to be answering two basic questions about the motion, and where is the object, and when did it get there? Okay. Now, again, like I told you, what we're going to start out with is you want to be able to describe visually the change in motion. Okay, so we can use two different methods to describe the motion without using numbers or without using words. And folks, make sure you get used to this here. Diagrams and models are very important. We already saw the importance of free body diagrams, and so make sure you keep that in mind. We want to be able, in the study of physics, to be able to draw very simple pictures to represent this motion. Okay, so I'm going to introduce to you two different pictures, two different ways that we can draw pictures here and describe the pictures. Motion diagrams essentially takes the pictures like we have here of a falling coffee filter, and we can trace the motion of this object based upon those motion diagrams. It's basically a series of images and the position of that image at a certain moment in time over a larger time interval. Okay? This is fairly, it's a simplified version, but it takes a lot of work, especially if you want to draw this here. You don't want to have to draw the picture of the object every single time. So we can simplify that by using what's called a particle model. In the particle model, then, what we're going to do is we're going to represent the object and its position time. We're going to represent the object with a single dot or some very simple symbol to represent the object. And based on that symbol, we can trace then the movement of the object. So here then, in this particular particle model, the dot, the aqua green circle then represents then the coffee filter. And the location of the coffee filter at different moments in time is represented by each one of those dots as it moves down. Okay, so this is what we refer to as the particle model. Okay. All right, so with that said then, we want to be able to describe the object's position. In order to be able to describe the object's position and assign a numerical value to it, we have to first of all identify or agree to a coordinate system. That is a system we can use to assign, and this is arbitrary, to assign the position of an object at a given motion in time. Okay, and so there's a few different coordinate systems that we can use. Okay. This was a couple different, we can use the Cartesian, we can use the plane, polar. So essentially what we're doing is we are identifying the object's position in space. Then because we want to do that, we want to make sure we identify, and again, a position where it starts out at, that we represent as 0, and then we move out from that. Okay? And again, the coordinate system here and the position of the origin is completely up to us. Okay? And so what I would like to do then is we'll talk about what the Cartesian system is. That is just simply the simple system where we have x coordinate and y coordinate. Okay, we can base the object's position and its relative location, relative position, if we can identify and agree on where the origin is going to be. Okay, all right. So the position then, based upon that particular coordinate, we can describe the position then as the separation between an object and where it started out at. Okay, so the object doesn't always have to start out at the origin, but it has to start somewhere. Okay, And so with that said, then we will also define then the frame of reference. Okay, the frame of reference then is the axis upon which the object will move. The horizontal axis then will be described as the x-axis, and if it moves vertically, we'll use the y-axis for that. But again, we're only looking at an object that's moving in one dimension. So either it will move horizontally, that is, it'll move along the x-axis, or it will move vertically along the y-axis. Okay, so that's what we will define as we move forward. So in this example here, if you take a look at this, then I have an example of two objects. Okay, we have one object that's stationary here. We have the person who is the catcher. We have a person who is the pitcher, and we have the pitcher standing on the bed of a truck. Okay, and so what we've done here is first and foremost, we're going to describe the motion of this object here, these objects in this frame here. We need to describe then the axes. Okay? So here I have then the x-axis and the y-axis, okay? Right? And each one of these represents a particular frame. So you can imagine if we were taking a picture, or this is a movie frame, this is the first frame, this is the second frame, and we're progressing forward in time as a result of this. Okay? All right, so let's go ahead then, and because of this then, we see then that the objects are not moving vertically. So we will not use this y-axis here. We're going to use the x-axis here to describe the motion of this object. And I'm running low on time here, so what I'll do is I'll finish this up really quickly. I'll ask you to do one problem in just a moment, okay, towards the end of this video, and then please make sure you write down your answer on Edpuzzle as well as writing on your paper for submission. But let me go and finish this then here, and what we've done here is we're going to identify this as the origin. Okay, so this is where we start out at. That's going to be 0. And the units that we use to describe length and displacement then is going to be in meters. So we will call this then, at this position, 0 meter. Okay. Now with that said then, if you take a look at the catcher here, he's off the origin. So we'll call this then, this point here, we'll call this about maybe 50 or 20 meters off the origin. Let's just arbitrarily assign that as a distance of 20 meters. Okay. Now if you notice here, in all three frames, the catcher does not move. His position doesn't change. Why? Because he stays on this 20 meters the whole time. And make sure you understand that as we move down from frame 1 to frame 2, time is advancing from time 0 to some time final. Okay, so don't worry about this right now. We'll talk much more about that tomorrow. But this then is time 0, which means that this is when we start looking at this interaction, at this motion. So this is the start time here. And then we'll call this down here time final, okay? And it'll be, let's say, 2 minutes, 30 seconds later. 30 seconds in motion, that is going to be our time final, okay? So if we notice here, from beginning to end, okay, the catcher does not move. So at time 0 all the way to 30 seconds later, he doesn't change his position. He doesn't get off this point here that we've defined as 20 meters from this origin. And so the catcher does not move. So what I'm going to ask you to do then is, I'm going to ask you in just a moment, and you'll write this down on your paper. I'm going to ask you then, how do you know that the truck is moving? So answer this question then on your paper. How do you know? And again, I'm not looking for a correct answer. I want you to try your best, and we'll go over this tomorrow. But how do you know that the truck is moving from this 3 frames here that we have here? So answer this question on your paper. I'd like you to answer this question here. Okay? How do you know that the truck is moving? Write it out really quickly, and I think you should be able to answer that question in 2 or 3 sentences, not much more than that. But describe for me, how do you know that the truck is moving? Okay, all right. And so I'm going to stop right there, and please make sure then, if you have any questions, comment in classroom, and also make sure that you email me and let me know if you have any questions. But if I don't see you, I'll see you tomorrow, and again, I'll have a second video posted for you. Please make sure you watch it and get your, and then if you have any questions, get your questions answered. Okay, folks? All right, have a good day, and hopefully I'll see you this afternoon. If not, I will see you tomorrow.